Okay, so today we're going to continue on with sequence operations. Last time we kind of went over, let's see, what? They won't go speak soon. Okay, I guess you're it. So what we're going to look at is, so last time what we did is we looked at common sequence operations, which were operations which work for any list, any tuple, string. So that we're going to continue on with that. The next thing we're going to look at is membership. So let's try this. Let's type in idle permissions equals RW. It is a string. And then say W in permissions. And so we're going to learn this new keyword, in, I-N. And you get true. So what this is doing is it's showing that if we have a sequence, which a string is a sequence, and we use the in operator, we can check if in this case, the sequence W is inside of the other sequence, RW. And it returns something called true or false. So true or false is what's called a Boolean. Later on when we learn if statements or while statements, we're going to find that that's going to be particularly useful for doing decision making. But for now, we're just learning kind of basically what we can do with our statements. So keep that in mind when we get to loops and conditionals. So try this. So let's say X in permissions. And what do we get? Get false. Right on. So there, notice that in RW there isn't an X, so you get false. If any of you have done Linux, that should look familiar. Read, write, and execute are the basic permission types for files in Linux, and so that could be an example, perhaps, of controlling access to different files. So now let's try this. Let's say users is equal to a list with MLH, foo, and bar in it, and then say, and instead of raw input, just put input. Raw input is 278, is a 271. We just need to have input. So I can fix that on the screen. So don't put the raw, just put input. And notice that here we're saying enter your name, and then we put in user. So what's going to happen is the person is going to type in their name, and then we're going to check to see if it's in the users list. And then when it says enter your name, type in MLH. So rather than raw input, just use input. You get true? So it's kind of like a password system. So last time we downloaded, so did that work for everybody? Did that work for you?
I got a. Oops. The only thing that worked for me with this.
Oh, okay. So go ahead and redefine user. Say user or users is equal to Or actually just type users, hit enter. Okay, yeah, go ahead and type in users equals that whole list. I think it was just maybe an S was missing at one point and
Okay.
it messed up. So there's there's day 3 sample programs. I'm going to download those. You may have already downloaded them, but if you haven't, download day 3 sample programs, and we're going to, and then I'm going to extract that.
Which is it? Is it online?
Yeah, it's on Blackboard. You'll see
Okay.
day 3 sample programs.
Okay, cool.
And what we want is we're going to look at the last listing that we haven't looked at yet, which is listing 2.4. So open that up. And you can open the file by right-clicking on it and saying edit with item. If you double-click on a PY file, it'll just run.
It's the program 2?
2-4.
2-4.
You see it? It should say day 3 sample programs, chapter 2.
Okay, hold on. Sorry.
Oh, no worries. There you go. First, hit extract.
I'm unable to make it run here.
Send me an email with the questions. I'm right now in the middle of class.
Oh, I'm in this class.
Oh, okay. Thought you were in. Yeah. Right click on it. Oh, first hit extract. It can't run the file in zip mode. And then hit extract. Yeah, replace files with destination. So it's priority. And then double click on it and then right click. Edit with I.
Oh.
There we go. Got it? Yes.
Thank you.
Everyone else able to open it? Yes, chapter 3, or chapter 2, day 3, not chapter 3, day 2. Sorry. Yes. It's this one right here, chapter 2, lists and tuples. It's this zip file down here. Does it look like that to you? Hold on, maybe it looks like this. Yeah, right there.
Should we edit the file so that we take out raw underscore?
Yeah, go ahead and get rid of raw inputs. Make them all inputs. Because we're running in 3 now. Let me see if this runs. And then our print, we need parentheses around our prints. Okay, there we go. Okay, so if you look at this program, we make a database. This is a sequence of sequence. And you can kind of think of it as row and column format in a way, but it really is just a series of sequences which is inside of another sequence. So each element in here is maybe a row, and then together all those form this entire table. And then we're going to ask the user for a name and a pin code. And notice, and now this is an if statement. And the way an if statement works is it checks what I highlighted to see if that returns true. Remember how in returns true or false? If this section returns true, then everything after the colon will be executed. If this statement returns false, then it will not do what's after that. So for example, if I put Albert as my username, pin code is 1234, it says access granted. I'm going to run it again. And now if I put Rob and I put 4321, that's not in there, is it? So it doesn't say granted. Notice also this, if I put Albert and I put 4242, will that work or not work?
It'll work, but it's not going to say access granted.
Watch. It doesn't say access granted. And the reason is that notice that what it's checking for is if, correct, Brendan, here this list constitutes the username and pin put together. And so you can't match one username and another pin because that would be a different thing than any of these would be. Does that make sense? You can actually use this to kind of specifically associate a name with a value. And then what we're doing is we're using the in operator to see if that combination exists inside of this database list. Pretty cool? Make sense? So the in operator, big thing to get from this is just that the in operator returns true or false, and we can use it with an if statement. By the way, you'll also see the if statement done this way, where there's a line of code afterwards. And basically, the way this works is the if statement will do anything that's tabbed in after the colon. And things. So this line of code here, which is inside, which is tabbed in, will only be executed if this statement here is true, between the if and the colon. This one will execute no matter what, because it's not tabbed in. Yeah, Brendan, you need to make sure that you extract the from the zip folder, otherwise it won't run. And it doesn't run? Oh, and then also make sure that where it says input, it says raw input, you change that to input, and then wherever it says print, you have parentheses around everything. Oh, you got it to run? Okay, good. All right, so so that's the in statement. So we did this one and got it to kind of operate. Now let's try this one. Create a list called numbers with 134 and 670 in it, and then say len of numbers. Len is the link operator. And basically what it does is it looks at the sequence you pass to it and figures out how many elements are in that sequence. and tell me what you get. Everyone getting 3? Yeah, so I should get 3. And so basically this is useful when you want to know how many elements are in your sequence. If you apply it to a string, it'll tell you characters are in that string. Now try this. You don't have to type numbers in again, you have it already declared. Try say max numbers, and what do you get?
70.
Yeah, it tells you which one is the highest, the largest element inside of that sequence. Say max 2, 3. And so you can actually use it, like you could pass 2 variables to it, and it would tell you which is the larger of 2 variables, or you can pass a sequence to it, and it'll tell you what the largest of 2 sequences is. So it's pretty flexible that way. Try min numbers. And it picked out the 34. And then you can just pass some numbers right inside of the statements. Say min 9, 3, 2, 5. You probably wouldn't use it this way. You'd probably pass in variables that you wanted to look at. But it should also find it that way. So fairly useful functions. So far we've been using using primarily lists. Lists are defined with open closed square braces. Unfortunately, that's also what we use for indexing and other things too, so sometimes that creates a little confusion, but when you have a collection of things separated by commas between 2 square braces, that's a list. Lists are different from tuples of strings, however. Lists are mutable, so you can change, once you declare a list, you can change your contents. With the strings and the tuples, they don't actually change. You can't actually change them. It'll look like it, but often what you're doing is you're creating a brand new list or tuple and assigning it to the same variable that was there before. Lists are really the only ones that you can modify after the fact. So try this, say list hello. So now what we're looking at are functions that are unique to lists. And the first one is the list conversion function. So if you say list and you put another sequence, for example, a string, it'll convert that sequence into a list. And notice that here we have HELLO as separate strings inside of that list. Make sense? Now try this. Say X is equal to the list 1, 1, 1. And then say X of 1 is equal to 2. And then see what X looks like. And try to predict what it will look like before you hit enter. Do you get X21?
Mm-hmm.
So here, which looks like an indexing operation, what we did is we assigned into the element of X at index 1, which is, of course, the first element is at 0, the second one's at 1, and then 2. So this middle one became 2. Does that make sense? So that's how you can modify things inside of a list. Now try this. Say empty is equal to the empty list. So if you put an open square brace and closed square brace, it's still a list. It's just it's a list with no elements in it. And then say, well, let's assign 55 into the element at location 5. Is there an element 5?
No.
No, because we made an empty one that didn't have any elements in it. What do you get?
I got an error.
So did I.
What'd you get online? Yeah, we get an error. And that's because when we initialize this list, there's 0 elements in this list, and then we try to put something to the 5th. We want to index 5, which doesn't exist. So the way we can do that is, here we're gonna make a better empty list, and we're gonna say none, the list with element none in it, times 10, and then show what better empty has.
Nuns.
Yeah, we have 10 nuns. So this is a way we can initialize a list, preparing to put things in it. And it's better to use none a lot of times because that means that you haven't collected the data yet. I have friends in the Forestry Service and they do data collection. And so if they were going to prepare a list to store, grass heights, locations around the state, you wouldn't want to put in the grass height initialize it as 0 because it assumed that all the grass was gone, right, to begin with. You'd want to use nuns because then if you were going to calculate an average, you would then only use the ones that weren't none. And so you get a true average even if you hadn't collected all the data yet. Yes.
So if lists are mutable,
Yes.
then how, when you do that last one we just did, it gives you the error instead of just like, okay, I'm going to put at least 5, then put that one that you just did into 5.
That could have been a way that they designed the system, actually. A lot of these decisions are decisions made by the people who made the programming language. In this case, though, what they decided to do is if it doesn't exist in the list, then, because then they would have to figure out what to fill the list with. And they could fill it up with nuns up to that point, but it's kind of an awkward thing at that point. So they just decided, okay, if it goes beyond the bounds of the list, we're going to say that it's not there. That doesn't mean it can't still be considered a mutable list, because if it does exist, you can modify it. If the spot is there, it can be modified. But if it isn't there, then there's nothing that can be modified.
One last thing, I see up there, none. Is that actually a keyword in?
Yes, none is a keyword, and it's a value that means the absence of a thing, as opposed to 0. So. Then if you said better empty 5 equals 55, we could actually put a value in. Brendan, just to submit projects, just upload the PY file, and then if there's test case involved, take a picture of your hand calculations or upload a Word document and include that also with your submission in Blackboard. So now let's look at this. Let's say that we're on Survivor, and Alice, Beth, CCD, and Earl are on the island, and we'll create this list of all names. So go ahead and type that in, and we'll say that Cecil threw out ice, and everyone's angry at them, so they vote him off the island, and we need to delete it. So the way we can delete is use the delete key. And you say delete names, and then put the index number, and show names, and it should remove that one element. That work?
Mm-hmm.
So basically what we're seeing here is we have a lot of things we can do with a list. We can initialize a list, we can initialize a list with nuns, we can change individual values in the list. You can use a plus to append something onto the end of the list, and now you can delete things out of the list. And you'd imagine, of course, if we had this functionality, we would have to have all these things to be able to work. So let's try this. Let's say name is the list of Perl. So we're going to take the string Perl and convert it to a list and store it into the variable name. And you should get PERL. And then take that, and notice now we're using that slicing thing that we did. What does colon with nothing after it mean?
To the end of the object. Or
To the
line.
end, right? So we're going to go from 2, we're going to say 2 to the end is now going to be AR. Try to predict what that's going to do before you display name. Which element is it indexed to?
R.
R. So it's going to take R to the end. Remember, we're 0 indexed, Laura. But you've got the right idea.
So it should be pair.
Yes. So index 2 is the R. We're going to go from R to the end and replace it with AR. Notice we also listed AR, right? So it's actually A comma R that's being placed in here. Try this. Say name is the list Perl, and then say name 1 to the end be the list of Python. Yeah, basically, Antonio, it's, you read this 2 to the end. So first find what the slice is. The slice is R in this L because 2, P is at 0, E is at 1, and R is at 2. And then from 2 to the end would be the R and L. So that's going to go away and be replaced with the A and the R. So we get pair. I recommend kind of doing it in that step. So here we're going to take Perl, P-E-R-L, and we're going to go from 1 to the end. So index 1 is which letter? E, right? So E-R-L is 1 to the end, and that's going to be replaced with Y-T-H-O-N. What are we going to get? Should get Python. So this is kind of a joke. Perl is a language that preceded Python. It was used a lot in to do kind of the scripting. A lot of scriptings that now are being done with Python. There's probably still a lot of Perl scripting out there somewhere, but they're both easy languages to kind of just write something quickly and get stuff done. Now try this. Say numbers is equal to the list 1, 5, and say numbers 1, only 1. So we're going to put 2, 3, 4 at 1 to 1. So what would 1 to 1 be? That's kind of an odd slice because it's inclusive, exclusive, and we're excluding 1, but we're including 1. So which element is 1?
3.
Or the 5, right?
I'm looking at the wrong one, sorry.
Yeah. So in the numbers list, 5 is at position 1. And so it's kind of hard to really make this kind of, be able to explain this logically with words. But what this does is basically says insert 2, 3, 4 before the element index 1. So basically this you can use this to do an insert. So I kind of think of it as insert whatever's on this side before the element at this index. So it's going to put 2, 3, 4 before the 5. Yes.
Is that how I did, like a few minutes ago, I did an insert on one of these lists just to see if it would work. And so in Python, when you're doing an insert, is it always, like if you specify the element of said list there, is it always going to,
Be the
Put it
one that's going to
before?
insert before?
yeah, is it
Yeah,
always before?
I believe so.
Yeah.
Usually they keep the logic pretty consistent throughout.
Yeah, because that's what happened. I was like, oh, I got it wrong.
But yeah, and that's one of the nice things about Python is they kind of keep it simple. So even if the rules are kind of odd, they keep them consistent. If that makes sense.
Mhm.
And then the reverse of inserting would be deleting a slice. So try declaring 1, 2, 3, 4, 5. It's probably already that because that's what made it be used last time. Try doing this. Numbers 1:4 equals an empty list. And so if I replace something with an empty list, it's kind of deleting. And we're going to go from index 1, which is to index 4. So 0, 1, 2, 3, 4. It will be 2, 3, 4, 5. Is that, so this slice, you might think it's 2, 3, 4, 5, but remember, the 4 is not included. So this slice represents 2, 3, 4. So basically it's saying, take 2, 3, 4 and replace it with nothing. And that defines deleting elements within a list. There are functions that do the same thing as these, but sometimes getting comfortable with these slicing operations can make for your code becoming a little bit more succinct. So did that work? Now, like I said, there are functions for lists that do some of the same things. When a function is associated with a particular type of thing, it's called a method, and the way you access it is take that type of thing, put it in a dot, and then you put the function name and its argument. So you're going to see this construct where there's a dot and then a function name. And so that, where it says object, that would be the name of your variable, whatever it is. And then the method name would be a function which is associated with whatever type of value is stored in that object. So let's create this list, 1, 2, 3. And the append method is before we used a plus to add two lists together. Well, the method way of doing that is say list.append, and then you put what you want appended. So if you say list.append, and then see what's in list, it'll be 1, 2, 3, 4. So it's a way you can add things. Make sense? And the reason why we used LST rather than list is because list is actually a keyword in Python, so sometimes you have to change your variable names up to keep them from
Colliding.
yeah, colliding with names. Try this, say to be or not to be dot count 2. So this is the count method. Normally you would put to be or not to be into a variable, and then you put the variable name dot count, but you can kind of do it directly here. And what that one will do is count up the number of instances of the thing inside the count method in the sequence that you're applying the count method to. That's different than len, which gives you the total number of elements. Count tells you, searches for a particular thing and sees how many times it shows up. So 2 shows up 2 times at the beginning and the end. Now, it can get kind of complicated when you have some nested lists. How many elements are in X? So in this case, is this 1 or 2 things? Is 1, 2, the list 1, 2, one thing inside of X or 2 things inside of X? It's one sequence. Yes, very good. So you have 1, 2, 3, 4 things inside of this, inside of X. So now if you say count X, count the number of instances of 1, what do we think the result will be? Two, or is there 1, 2, 3, 4, 5? Yep, 2. And the reason is that the list 1, 2 is not the same thing as the number 1 by itself. The list 2, 1 with 1, 2 inside it is not the same as a 1. So if we counted up the number of 1s here.
So Python doesn't peer into the list. It doesn't.
It doesn't dig into the list. It just looks at the first layer of stuff and then looks at those and says, is this a 1? No, this is a list. Okay. Is this a 1? Yes, that's a 1. Is this a 1? Yes, that's a 1. Is that a 1? No, that's not a 1. That's a list. Then try this. Say x.count the number of instances of 1, 2. What do we think the result will be? So try to pick the result and then hit enter. And we can see this first one is there. The key is that the second one is embedded in another list. So it'll only come up with 1. You don't have to, you don't muck around with this kind of stuff a lot, but sometimes you may have some complex lists which are nested out, kind of, and especially if you're reading a website, we're going to do some screen scraping later, and sometimes those things can be nested out kind of weird. So another method, the extend method, say A equals 1, 2, 3, B equals 4, 5, 6, and say A extend B. And then see what happens with A. And what you'll see is, notice that what happened is we didn't have to concatenate 2 things and then assign it back in. With the extend method, it automatically adds it to the first variable. So this is kind of like append, or this is like concatenating 2 lists, but it also stores it in the first one. That work for everyone? And then if you try to do it with just concatenation, A plus B, notice that when you do A plus B, you get the same concatenated list. But then if you look at A, it hasn't changed A. You would have to assign that back into A. You'd have to say A equals A plus B, and then A would become the concatenated list. Make sense? Now this one's going to be important for the next program. Say knights equals we are the knights who say me, and look at knights.index who. And what you'll get back is 4. So what the index method does is basically whatever you pass into index, it will look for in the list, and it'll give you back the index where it is. So if we look for herring inside of the knights who say me, what do we expect? We'll actually get an error because it doesn't exist inside of that list. So whatever this is, it's going to look for it inside of the list, and it'll return the index. So notice that who, we is at 0, R is at 1, B is at 2, knights are is at 3, and who is at 4. So that's the index method. It's kind of tough because we have indexing with the square braces. Then we use square braces for lists as well as doing indexing, and then we have slicing with the square braces. So if this stuff starts blurring together, it's understandable. The other methods, another method we have is the insert method. If we have numbers with 1, 2, 3, 5, 6, 7, go ahead and type that in, and then say numbers insert 3, comma 4. And then display numbers and tell me what you get. So what does this represent?
Location of the, that list.
Yeah, and so which element is the index 3 element in the numbers?
5.
The 5, right? And we always do our inserts before in Python, it looks like. So the 4, the FOUR is going to be inserted before the 5, which is we'll get 1, 2, 3, 4, 5, 6, 7, but with 4 spelled out. Make sense? The other thing to notice is, do lists have to have all exactly the same type of object in them? No, so you can mix and match inside of lists. You can put strings and other lists and numbers, and however you want to describe your data. There's also a way of doing that with slicing, and we saw that before. If we said numbers 3:3 equals 4, you get the results. So they're equivalent. It's just which style you prefer. Whether you want to use a method or you want to use slicing to do that. It's, in some ways, I think it's kind of elegant to use the slicing method. It's probably good when you're starting to kind of make yourself do that a little bit, because that will help you with really taking advantage of Python. Most languages use functions and methods to do things, but understanding these types of operations with Python is what makes it unique. Okay, another method, the pop method. Create a list. X is 1, 2, 3, and say x.pop. And you should get back. Does everyone get 3? Yeah, actually, I think everyone should get 3 of this. Yeah. So what pop does is it returns the last element on the list and then actually removes it from the list at the same time. So you can imagine maybe if you had like a bunch of email messages and you were writing a handler to handle this list of email messages, and it would just regularly go in a continuous loop. Whenever it would just pop the last email message, send it off, and then grab the next one. And then and then it was running at its own process. And then you had other parts of your program which were just loading email messages onto the list as they went along. That would be an example of doing this. And you might set up your email message sender to do it maybe like once every hour, so you weren't spamming someone, an inordinate amount. So that could be used for something like that. You can also specify the index of which one you want. So there they grabbed it first. So you can use pop to remove things from the end or the beginning. And then there's also the remove method. So you can say x is equal to b or not to b. If I do a remove, it'll actually look for the first instance of that. Notice that it got the first one, it left the second one in place, and then it removed it. If I try to remove something that's not there, you'll get an error. Later on, we'll learn how to handle errors so that you can actually, if someone's giving you input, you can try to remove it. If it doesn't, then you would give them an error message, but we'll see that later. There's also the reverse method. X.reverse will actually reverse that. So a common question in interviews is reverse a string. You say, oh, I'll just use Python and I'll just put string.reverse. I say, okay, that's funny. Now do it in C++. But anyway, there's a lot of convenience functions in Python. Sort method, if they ask you to write it, you can tell the difference between a software engineer and a computer scientist. If you ask a computer scientist how to do a sort, they'll sit there for about an hour, walk you through a really cool algorithm. If you ask a software engineer how you do a sort, you say, well, you just put dot sort, and it sorts it. So the sort method will actually take whatever you have and sort it. There's some interesting things about sorting. If you say you have a list like this, and you sort it into, say, Y, and you print Y, you get none. Because X.sort actually doesn't return anything. It sorts X. It'll actually sort X, but it doesn't actually have a value itself. It's kind of weird. So if you want to make a copy, the way you'd have to do it, you say X is this list, and then you say make a copy of X. If you just said X equals X, what would happen is you'd have X and Y pointing to the same list. And if you sorted one, both of them would be pointing to the same sorted list. To make a distinct copy of an existing list, what you do is you say Y is equal to the other list, and you say from the beginning to the end. This will actually make a duplicate copy in a separate place in memory. And then when you sort that, X will not be changed, but Y will be sorted. So this is kind of a weird aspect of it. And in Python, we don't get into pointers and how things work in memory that much, but realize a variable is really just a pointer to something in memory. When you make a copy of a variable, you're making a copy of the address it's pointing to. So in order to make it actually be a distinct thing, you have to do this little hack here, where you say, make another one. That's basically what that's doing. And then here's another wrong way to make a sort of a copy. You say Y equals X. These are now really pointing to the same list in memory. If I sort Y, and then look at X, I find that I sorted Y, but X is now sorted. That's because they're both pointing to the same place in memory. Now, this will not make intuitive sense necessarily at this stage, but here's how you use this in practical terms. You made a list, you made a copy, or you thought you did. You modified the copy, and then you see the original was also changed. Now you know that you really don't have a duplicate. You say, okay, I remember I said something about that. You open your book back up to this chapter, and you go through and look for this colon thing, and then that fixes the problem. The other way is you can use a method called sorted. Sorted is a function. Notice this is not a method. This will actually make a duplicate copy of the list, sort it, and then return it as the output of this function. And you can assign it into a different variable. In this case, X will not be modified, but well, Y will be modified. We won't get into advanced sorting, but you can actually change the criteria you're sorting on. So far we've seen it's sorting on, what's the least, the order of the numbers, but you could make some criteria. So let's say I wanted to sort alphabetically by the date. So for example, April comes before January, or some weird criteria for whatever reason. I could make a function to define that, and I could actually use that. We won't go into this. It's a little bit more complicated than I want to go at this level. And we don't need to go into all of these either. The next one that we'll go, so those were the unique operations for lists. The next one we're going to look at are tuples. Tuples, unlike lists are denoted with square braces. Tuples are denoted with parentheses. And they're very similar to lists, except that they're immutable. Once you create them, you can't modify them. Go ahead and type 1, 2, 3 and hit enter. You should get the same thing in parentheses. In Python, anytime you have something separated by commas, Python's going to assume that what you meant was a tuple. So tuples are actually the default list type. So normally you would type a list 1, 2, 3, you'd see that it gives the same thing. You can also make an empty tuple by putting open and close parentheses. Then the question comes up, let's say we want to have a single value inside of our tuple, just a 42. Go ahead and put 42 in parentheses, and what do you get? You just get the number 42, because in that instance, it's just thinking you're doing the order of operations things for math. Mm-hmm. To fix that, what they did is they said, if you put a comma after a single value, it's going to interpret that as a tuple. And a tuple with a single value is that value with a comma after it inside of parentheses. So that's what a single value tuple looks like. Does that make sense? So it's just they had to figure out a way to represent a single element tuple, and that's what they came up with. Now let's look at this. 3 times 40 plus 2 will give you 126. That's just the math expression, right? But now put 3 times 40 plus 2 with a comma. You get 3 42s? And that's because this comma turns us into a tuple, and now we're really just multiplying sequences. That'd be a pretty easy mistake to make too. Maybe, like you're doing something, you left a comma in. There's also an equal function that will convert. It's a conversion function. Here we're passing in the list 1, 2, 3, saying make that into a tuple, and it converts it into a tuple. Pretty much in Python, you can convert anything to something else by putting the type that is a function name, and then passing the thing you want to convert in parentheses. And whether it's a string or another list or whatever, Python will do everything it can to try to convert it into that. If it's at all possible to figure out how to do it, otherwise it'll give you an error. You can also convert a string into a tuple. I guess here we're converting a tuple into a tuple. Let's do so then there's some basic tuple operations. Here tuple 1, 2, 3, and we're going to find the index of element 1. What should that return? 2. Just like with lists, just like with that we're just saying. You can also slice. That's going from index 0 to 2. 2 is not included, so it gives us the 1 and the 2. So why would we use tuples? Later on, we're going to talk about dictionaries. You can use tuples as keys. You can't use lists. They are returned by some built-in functions. There's a lot of functions that will naturally return a tuple. And so often you'll use lists, but there's times, especially if you're not going to really modify something, it's probably better to return it as a tuple. So let's look at, actually, a 10-minute break, and then while you're doing that, bring up the spec for program 2, and then we're going to discuss program 2. And we're going to be using that index function we talked about, or index method. Actually, let's just make it a 5-minute break. We'll come back at 35 after. Okay, so let's see. So the next program is, we're going to write a program that will display information for state typed in by the user. When the user types in the name of the state, your program will tell them the state's capital, number of congressional districts, and the order the state joined the union. So it looked something like this. Welcome to State Info Finder. This program will tell you the information for a state you input. They type in the state like Alaska. The capital of Alaska is Juneau and has 7 congressional districts, and it is state number 22 in the union. Thank you for using State Info Finder. So that's what your program will look like. So how is it going to do that? So to do that, you're going to initialize a few lists to store information about the states. You should have one list for the name of the states, one list for the names of the capitals, one list for the number of districts per state, and one list for the order number the state joined the union. And then alternatively, you may have seen like where they create a database and then there's multiple lists underneath that. You could do that too. There's a number of ways you could set this up. Some people try to set it up where they have one element that has the name of the state, the capital, number of districts, and the order joined. That's actually going to make this harder. It is possible to do it that way, but it's easier if you have 4 distinct lists. Because what you're going to do is you're going to ask the user for the name of the state, and then you're going to use that index function. So just kind of review the index function. You could do so, so if I said, and I had another one that was numbers. I could say, maybe what I'll do first is I'll print my list. So let's look at that. So I've got 2 lists. One's got a numeric equivalent of the string. And I ask the user to, I'll print out the first one, and then I have the user type in the choice. And then I'm going to just display what the index is. So if I run this, it's going to ask me in their choice if I put 2. It tells me that 2 is at index 1. Does that make sense? If I wanted to display the numeric value from the second list, so knowing that the index is at that index here, this index list, knowing that, how could I get the number out of there? So for those of you online too, what code could I write here to get the numeric value here now that I know what the index is of this element that the user chose in the string value there? So I could take numbers and then use the square braces to use that. Back over here, you can kind of play around with it by print numbers. I can see it's 1, 2, 3. If I say numbers at index 1, I get 2. That's what I want to end up with, right? So this 1 is really this index and list I got from this index function. So I can get the user's choice in one list and get the corresponding value in the other list by using this index method. These are called parallel lists. These two lists are parallel because one corresponds to this element, the second element corresponds to the second one, the third corresponds to the third one, so they're parallel. And we can use that to kind of basically make a lookup table. If I run this now, if I put 3, I also have to spell correctly. I don't know if you noticed that about programming. Oh, and then I should probably print this out. One day someone's going to make it do what I mean, not what I say. Module. And now it's able to correctly translate this over. Oh, I put a capital. So you can see it was able to find, it's now able to find it. So this is called a parallel list structure. We have two lists, they're parallel. We ask the user for the choice in one. We use the index method to take that user choice and get a numeric value or an index value for where that's located. Then using that, we apply it to the second list and we get the value. What you're going to do with this one is use that same principle. Only now you have 4 lists. You have the name of the state. You have the order to join union is capital, etc. And you're just going to ask the user for the name of the state. Use the index function to find that index, and then use that number to look up the other values, and then formulate that into a string that says something like capital Alaska has 7 congressional districts and it's state number 22 in the union. Makes sense. Kind of, yeah, as you dig into it, you do that. But you can do this, the way I would do this is a piece at a time, the same way we did. I would just make the state list and then the capitals. Get it to work for those first. Initially I would just print out the index. See, does the index line up? Okay, then use that index, with the square braces to get the second value out. Okay, I've got that. Now, then I'd go back and put the other lists in, and then try to get those in. And that would just display the values before I make the whole sentence. And then once I have the values come out, then I'd kludge it together into a sentence, and you're done. So a lot of programming is figuring out how to break the problem down into small pieces and do a piece at it. And it's not always linear. In this case, it's pretty linear. Make the first list, get the person's input, use that to get the number, so you've got the number. Okay, add the second list. Take that number, pull it out of the second list. Okay, now we've got 3, 4, 5, and then we're done. So,
Okay.
make sense? Does it make sense online? So the rest of this is lab time. If you're online, I think you all are online as presenters, so if you have a question about your program, let me see if I can go over and illustrate how to do. You get this cool going into the past spec. But over here, there's a share button. And you can actually, you should be able to go in here and share an application or screen. So one way that you all can get help while we're in lab time is just post that you have a question, post me the question, and then share your screen, and then I can look at it and maybe answer it. Does that make sense? And also, that's a way, if we can't make an appointment where we can be, you know, at the school or something, we might be able to make appointments where we meet online through Collaborate, and we share our screens back and forth, and I answer your questions that way as well. So it provides some pretty neat capability. So I'm going to stop sharing my screen, and that way, if anyone has something that they need help with, they can bring it on, and the rest is lab time. So the current program is Pyramid, I believe.
Hey, Rob,
Yes.
so for the, someone asked, so you asked for the state first and then find the index of that name?
Yes.
So would it just be like what we just did?
Very similar. So we're,
So state equals and then you just put all the states in like,
yes.
right? Okay,
Oh, and I forgot to mention, 10 states, you don't have to do all of them.
just 10, okay,
Yeah.
cool. I was like, oh.
I mean, you can actually go and grab a list, and you can, you know, you find one that's nice comma separated,
Yeah.
and you can just copy and paste it in.
Oh, yeah.
But, and then the state info is available on this thing called the interwebs, so you can
Okay.
find the stuff there.
Cool. And so with the numbers, would we just put in, like, leave that?
Yeah,
And
you
just
would.
Put 1, 2.
Yeah, so the capital, so you have states as one list, and then the capitals is another. So the capitals would be, you know, strings.
Would it be the
But-
index, the capital, or, like, I'm a little confused, I'm sorry.
Well, so for example, if you had the names of the states, right? And then the second list had the names of the capitals for the states. Once you get the index off the first one, you know, you ask the user for which state you want, you use the dot index function to get that line.
Okay,
Then from then on, to get, you can use that number to get all the values from the other lists. So you would just say, you know, the capital is capitals, open square brace, you know, and then that index value variable.
okay,
And then you could say then you have 2 more lists. One says the order they joined the union, which would probably be numbers. And then the number of congressional districts should be another integer, list of integers. And you'd use anything to get those values.
okay.
Yeah, and someone's kind of come up with an idea. Now, we haven't learned if yet, Antonio, so most people wouldn't be able to use that yet. But the idea is you get the index from the first one, as Antonio has here, and then he's applying that index to the other list to get the values. And in his case, he's using it if else, to check first to see if it's in there. But you're not required to do that at this stage, because we haven't got there yet. And, you know, as a first iteration, you can just put the list of states and just try this, you know, get this, you know, the list of the states, get that, call that index function, get that number, just print that number out, and you'll see what happens.
Okay.
Yes, just to, if you want, you can just use round. Good question on whether you need to do capitalization. No, I'm not going to require you to do capitalization. The one thing you could do to handle that, I don't know if we've gone over it yet, but you could do dot lower on the string. And that will lowercase, that you could, the key to that would be that in your list, you would store all the names as lowercases, and when the user inputs their value, you would use dot lower to make the user's input lowercase. So you're comparing lowercase to lowercase. Oh, Richard, yeah, you could use the format specifier too. That's another way you can round.
Okay. So for the
Got your
list,
states, got your
Yes.
name. Okay, so you went ahead and built.
just like kind of the list that I need, I haven't entered everything, but would that be what it looks like?
Well, what I would do is go ahead and initialize these two as well. Otherwise, it's not going to know what to do with those. So
Just-
put like equals, and then you could put an empty list or something.
Okay.
For now. Or put some dummy values for now. And you have an extra combo there.
Oops.
So now that you have those, then you've got the user entering. So why don't we make that phrase a little better here?
For a state,
Yeah.
okay.
And then maybe get rid of that numeric equals, well, yeah, get rid of that for now, or
Original.
comment that out for now.
This one right here?
No, there's one above it. This one right here, comment that one. Just put a number sign in front of
Yeah.
that. And then just print out what your index and list is.
So, the index.
Now we just change this to index and list.
This one right here?
Yeah, get rid of numeric and yeah, just say index. And then over there it says numeric, change that to
List.
index and list. This one right here. And run that. My list is not defined, so somewhere it's referring to,
My list. Oh, right here.
yeah.
Should I just get rid of that right there?
No, you could use it to print out the states,
What are the states?
just your list state,
Lists.
or just this name right here.
I'll just state. Wanna run it?
Make sure the capitalization is the same. And run it.
Is that supposed to show up right here?
Yes, because we're printing a list, it's going to be
It's gonna
be
show right here.
show up like a list.
Okay.
Yes.
So, not letting me type in anything.
Yeah.
Enter state, right?
Well, you've got an input statement. It should work. Maybe click over to the right here. Now type.
There
There
we
we
go.
go. Type in one of your states. So what's wrong? So look at the line number and then click over here and it'll tell you the one that you're on the right.
So 8 right here, something's wrong right here.
So read the line slowly and carefully like your computer. Everything has to be absolutely correct.
Oh, it's the. Forgot to use.
Capital.
Yeah, I'm always doing that.
One convention we often use is for variables. Often we start with lowercase.
Yeah.
That way it cuts off
That way
50% of its mistakes. The other thing I can do is you can always copy and paste your variable names. Once you grab it once, then just copy and paste.
That's nice that you can do that. I'm been working with Linux and it doesn't let me do that and it drives me crazy.
Yeah, and there's a neat technique where you double click on an item and it'll highlight the whole word. Then you hit Control C, and you go where you need it. You click there and you click Control V. So Control C,
Oh, yeah.
Control V,
Yeah.
and then double clicking will select
Okay.
the whole word. I do that all day long.
Okay, so. Did you want the index on here?
Yes, so it says 0. Is that the correct index?
Yes.
Now, while you're here, type in this variable name, a number of districts and states.
Just all.
Yeah. You might want to copy and paste it. It's pretty
Yeah.
long. Just double click on it. No, try it again. Control Z.
Control Z.
Yeah.
Okay.
Double click on it. See how it's highlighted?
Oh, yeah.
Control and then copy.
There we go.
And then down there,
Control Z.
Oh. Control V. And then now type it in again. And how could you get the 0th element out of there?
The 0.
Yeah, if you want to get the first element out of this, the 0th one, you put square brace, right?
Square brace and then X. right?
Well, what's the variable that's holding the index right now? Hmm,
1. I don't know.
well, put a 0 in here for now and see
Okay.
what happens.
Close it off.
Yep.
1.
And that is the corresponding value here, right?
Yeah.
So that, we can see that we can get that out, but we need really, what we want to use is a variable. So go ahead and type that back in. Yeah. And then put a square brace. And then inside the square brace, there's a variable that you have in there, which is the index that was figured out from the state. So try to find which variable that is.
Would it be 1?
No, it's, so we got the state, the name of the state, and then we use that name of state with the name of this, we said state dot index, and then the user input, and
Choice.
it was stored in something. What was it stored in?
User choice? Or
The-
the index list?
Yeah, index and list.
Index and list, okay.
So actually erase this and type index and list. It's got the 0. So that so the state came in here as a string. That string was passed into the state list, which found that it was at index 0. That 0 was stored in index list. So if we were to put number of districts in state and put index and list instead of 0, what would we get? Give it a try.
So the number of. But index,
Yeah, with the
List?
square brace.
okay.
And now you got the element from the other list, which corresponds with the list in the state. Does that make sense?
So it's wrong?
No, it's correct.
It's correct?
Yes.
Okay,
So what we did is we asked user which state they wanted. Then we took that name that they gave us, and then we used the index function to figure out which numeric value it was in.
yeah,
Then we took that numeric value, applied it to the other list, and got the value in the other list which corresponds with that state.
okay,
And that's that parallel list thing.
okay,
So now imagine that we had multiple lists which had all kinds of information about the state.
Yeah.
We get the index of the state and then we grab them out of it. So it'd be kind of like, let's say we had a card catalog, right? And you go in and then you have, and so we go through the card catalog and we get the location of this book. Then we go to that book, we go to the shelves and we find where that index
Yeah.
says, we find the book.
okay,
So that's kind of what's going to happen here.
okay,
And only, rather than one set of shelves, you have multiple set of shelves, so you can find that same number in multiple shelves and get all the pieces of information which are associated with that one element. This is kind of a lookup scheme.
okay.
And the way we kind of look at it is this. So, so we get Colorado. We now know that the index is 1. I take index 1. I know that I'm going to Denver, and I'm pretty sure Denver, Colorado's not the first one.
Yeah, but yeah, I get
But you get the idea.
Yeah.
So we find, it's basically the idea of a lookup. This is a pretty powerful way of storing information when we want to do a lot of lookup type of stuff.
Okay. Okay, cool. So when I get all that done, should I just hit like for the last, like when it tells you like what the state is and like all like the different information, should I just hit print and then reference back to my list?
Yes.
Okay.
And I would initially just print out the values, don't get too fancy about the
Yeah.
formatting. Once you're confident that you can see that it's working,
Okay.
then you can kind of rewicker it to make it
Okay.
into a sentence.
So just don't make it fancy yet.
Yes, and that's an important part of programming is initially just get the basic functionality work, and then you can iterate and change it later.
Okay.
And so, you pick one little tiny problem. I wonder if I can do this. You do that, and you may try to make it work. So you write whatever your best guess is, get it, and sometimes what it is going back to previous examples of code. And I've even gone through and taken a previous example of code, even though it doesn't look anything like what I need. I put that in my program, get that to run, because I'm just copy and paste it and
Yeah.
it runs. And then I start making little modifications
Okay.
to get it to work.
Perfect.
Okay, for everyone online, is there anything that I've missed that you need me to answer that I have not answered? Oh, I think I'm the only one left.